Hey there, welcome to dotnetFlix. Today our guest is Jurre Brandsen. And Jurre, you're going to talk about generative AI, right?
Yes, I am. Yeah.
Yeah. Well, generative AI is a big space. There's lots of stuff that you can do. So I'm very curious what particular case you're going to talk about today.
Yeah. Well, first of all, thanks for having me here. Um, the thing I'm going to talk about is actually a story from the trenches. It's a story
Hmm.
that we did in the early, at the beginning of 2024.
Hmm.
And that already feels like it's not that long ago, but in AI world, this feels like it's been forever.
Ages ago.
um,
Yeah,
Ages forever. Yeah.
yeah.
So yeah, we really learned a lot about it, and I'm keen to let you share my insights of it.
Awesome.
Um, and the first thing I want to show you guys is something I hope you are all familiar with, and that is the test-driven pipeline, just-in development pipeline,
Hmm.
where you first write the test, and then of course it starts with red, and you try to make it green, and that is the development cycle that we all know and hopefully also love. But in the AI world, it's a little bit different because what we see happening if we are trying to make some or yeah create code using this generative AI, we actually see that the cycle reverses a little bit. So
Mm.
first we generate the code, then we need to clean the code, and we do that by using just standard engineering tools, and afterwards we can generate some tests and then try to iterate on that. So that is something that I want to show you guys in this episode also, is that we reverse the process of development using this generative AI.
Okay,
And
software lifecycle development is also something that you do with AI because I hear a lot of developers always talking about, well, what these guys is doing is just they just type something in an editor and they just press run, but there's actually some lifecycle development behind that. So that's good to hear.
yeah, exactly. Yeah, it's we are trying to also make this some kind of iterative development, instead of
Hmm.
just pushing a button and it goes inside of a black box and then you wait until something happens and you see the result. You try to also make this an iterative process, or yeah, put it in your lifecycle development.
Cool. I'm curious to see how you guys did that.
Yeah, so the case I want to share with you guys is a very simple case on paper, but well, in reality, it's always more difficult than you think. So we had a client that actually wanted to transform its code, going from XML, and he wanted to go to a modern development stack using TypeScript. So in the front end, we had Vue, and in the back end, it was Node.js. And this was quite a repetitive task because he did not have only one form, but there were 25 web applications that needed to go through this transformation process. And doing it all by hand is quite tedious a job. So we were actually asked to do this with AI. And then if you have a nice set of prompts, you can rerun it 25 times, and hopefully at the end you have 25 of these web applications. The first thing that we actually tried is just putting the entire XML file into the AI. But of course, this doesn't work because XML is quite a verbose language, meaning that it generates a lot of code. So one single web application consisted of roughly 50,000 lines of code, and that does not fit inside of the context of this AI. So it would have been nice if this worked, because then we worked on in like a day and we could present it back to the client and say, hey, well, it's done. But unfortunately, that was not the case. So we needed to find some kind of way to actually try and cut this.
So Jurre, when you talk about these XML files, what kind of
Mhm.
front-end technology was used that used these XML files?
Yeah, it's actually a good question. So it was a low code solution. The low code solution is called Bluerig. And of course, that has some advantages because then you can, it doesn't really require programming skills, because you
Mhm.
can just, like similar to WordPress, you can just drag and drop some kind of components, and then you have a website. But the thing that the clients noticed is that it is also really restrictive to use low-code environments, because if you want to do something custom, then most of the time there's not really like room to do that.
Yeah.
So that is why they wanted to transform from this low-code environment to a modern development stack.
Okay, and so those XML files, they contain both the design of the screens as well as the logic?
Yeah, so because it was a low-code environment, it doesn't have any code necessarily. So these XML files, these are actually they are the exports of Bluerig. So
Right.
it contains some kind of logic, but not necessarily. And that is why the transformation process is also quite a bit difficult, because you don't go from a C# to Java, but you need to go from a programming language in which we don't necessarily program, like XML or JSON or anything like that, to actually code that people can maintain. So that is also part of the challenge.
You have all the information there, but it's not very similar to the output you want. You need to make quite a translation to get to TypeScript in this case.
Yeah, exactly. Yeah.
Okay.
Yeah. So going back to the story, so the first approach, this didn't really work because the files are too large, and it contains a lot of information, and we need to extract little pieces of information. So of course, then you can try to cut, just make random cuts in the files, and you feed it to the AI and you write a nice prompt, and of course you get some kind of output. But we as programmers, we know that, okay, if we try to develop this web page, then we maybe we build some kind of form, and this form has a button, and there's all of this logic going through the file. So if you try to cut this file, you say, okay, maybe every 100 lines of code we make a new file, then a lot of these references are lost. So the AI couldn't really make anything out of it. It just produced rubbish, because our input is then also rubbish. So this also didn't really work. And of course, it looks nice if you if you put it here on the screen, but it didn't really work as well. It's actually nice that you asked me this question, Sander, because this is actually when we try to look at what's inside of this XML. Because it contains all of this logic, so the logic is here, but how is XML making like soup out of this logic? And we saw that it has some really nice references to pages, and these pages contained containers, and containers had references. And with this, a page was actually built. So using those building blocks, those exact building blocks, and we scripted it out of the XML file, we could actually make some really nice tiny pieces of XML, but then keep the references to those buttons, to those input fields, stuff like that. So that is actually where the golden key for us lied. And here you can see that as well, that we have on one hand we have the content, those are the headers, the navigations, the buttons, stuff like that. And on the other hand, we have these references. They are called containers, and they reference pieces of content. In the final approach, we could really extract what we needed from the code. So we extracted pieces of buttons, pieces of forms, and pages, feed those to the AI, and then as software engineers ourselves, we could like link them together in the actual code. But this is all nice that I can show you this on the presentation, but I can also show you this in the code. So maybe let's dive into the code. So actually, most of the programming in the AI world is actually done in Python. So all of the .NET viewers, they are now they are now ended the video, and only the AI people are now left, because of course Python is not C# or .NET, so I'm sorry for that. But that is the way that AI goes. So you have to bear with me. But actually, what we made is quite a nice thing that we did, because our code is essentially what we call a state machine. And a state machine has these graphs, and these graphs, they can interact with each other. And this is also why it's called Graph Catalyst, by the way. And we define different states in which this graph can be. In this graph, different states can be activated. So we have a state for the model, so the model that can run. We have a state for the human, so the human can ask prompts. We have a prompt controller, which makes the prompt a little bit nicer, and also some kind of code extractor state. And these are linked together, and we can go through them freely. And the next thing I want to show you is the model, because this model, if you work with LLMs, let's say ChatGPT, then you know that you need to feed it prompts and feed it information, and based on those prompts and information, it gets you results. And the same we need to do in this code as well. And the first thing that we actually need to define is what we call a system prompt. And the system prompt really sets the tone in how the model is actually going to respond to you. So here, what you can see is that we created a template, and we say, oh, you are a software engineer, you are extremely good at transforming code into different languages, and then especially converting websites from XML to a Node.js background and a Vue as the front end. So it's already a little bit primed to know, okay, if I receive some kind of prompt or some kind of code, I actually know what my role is and what my ID is. And based on that, it can produce, the desired code that we wanted. Also, a really nice thing that we can use, because we're using this really nice library called LangChain. So we can store our previous conversations with the AI, so we can also iterate on the conversations that we have. So you see here that we have a previous conversation, and there's this chat history. So it knows if you asked him something, he knows he knows that you asked that, and you can also iterate on that and really get some kind of interaction with it. And then it waits on this human question.
Jurre, because this history is of course nice to have, but does this also influence the answer? So that does it take the history along when it starts working on new answers to your questions?
Yeah. So
it becomes part of the context actually for the
exactly
model. Yeah, okay, cool.
Yeah, because one of the things that we something that we really used in this process of converting this code is actually talking with the LLM, and we could do that via the chat history.
Okay.
Because of course, we never have transformed this code from XML to TypeScript before, and also not with using this large language model. So the prompt that we needed to write for this needed also to be figured out. So here we could just ask the model what it actually wanted from us as input. And this is where we can use this chat history. And this is actually a phenomenon that we call a human in the loop. So we have this iteration loop of our development cycle, and we try to automate large parts of it using AI. But it's also nice to have this human in the loop that can say at any moment, wait, stop. This is actually not what I expected. I actually expected something else. So please tell me what I can do to inform you better, essentially. So it's actually like you're talking to a colleague or someone else, which you can have some interaction with it.
Yeah, some kind of a personal assistant, maybe.
Exactly, personal assistant.
Cool.
So, and what kind of model are you actually using for this?
Yeah, so the model that we're using is actually the OpenAI model, the newest model. So I think it's 4-0 we call it.
Yeah.
4.0. But at the moment that we did this case, we actually needed to use 3.5. But that is no longer available because there were so many questions put into that model that the model became a little bit confused, and it actually stopped working. Because if you ask it a question now, it will just say, well, do it yourself, essentially.
It gave up like a human.
Exactly, yeah. And this is also the reason why like OpenAI keeps releasing new models, because the older models, they just become polluted with trash, because we as human, we put a lot of trash into that, and they use it as training data. But if I keep telling it, grass is not green, it's blue, then it starts to think, okay, grass is blue.
Yeah.
So that is why they need to keep updating these models.
Makes sense.
But yeah, the model, and that's also the thing. Like the older models, they required a lot of really like what we call this prompt engineering. So you needed to write large essays of telling it, oh, I want you to do A, B, and C, and if it's possible, then also D, E, F. But what we notice with the newer models, we can be just a little bit more straightforward and just say, okay, please transform this code, and it already will produce some really nice code. Which is also my bridge to the to the next demo, because I want to show you a little bit. Okay, how did we do this human in the loop part that I talked about? Because if we take a look at some kind of XML code, so this is the anonymized XML code which I extracted from the case that we have. What we see here, and you don't necessarily need to know every details, but this is some page which contains a form, and in this form you just need to fill in your first name, your last name, your phone number, stuff like that. And the first thing that you notice is, whoa, there's a lot of information on this screen, and I don't necessarily know where to look to find all of these things. But that's not for me. that is something that the AI needs to solve. All that I have to do actually is just give it a prompt. And I put this here in this config file, and also the code it's a little bit what we call this minimal viable product code. I just want to show you how it works, and it's not really clean at all. But just to get some idea actually how it works. So what we can do, or what the code essentially does, is it will give this prompt to the model. So we actually feed the prompt that we wrote to this model, and it will be pasted here in the message. And then what our graph does, the model, it will also extract this XML file, and it will bundle it together. And those, the prompt and the XML file will be the input to the model. And we can call the model just by running our main, and you can see that it boots, and it goes through the different states that the graph actually goes. And here now the agent is working, and the agent is getting this input and then transforming the code into view code, because while we wait, we can see that is actually the prompt that we gave it. It's a really simple prompt: transform this XML file into view 3 code. But of course, because it's quite a large XML file, it will take a couple of seconds. And you can see here that it's now done. And we can look at the results. So the result is shown here. And the first thing that you see, and this is something I get excited by every time that I run this, I run this model, is we actually see already a large piece of code, which is actually already very good, because you see, okay, it has some kind of logic. So it sees, oh, maybe the user needs to be logged in or not. It knows, oh, hey, it asks for a gender, it asks for initials, stuff like that. It also already has some kind of pattern matching, so validation that we can see. Yeah, it already has quite a large part of actually that I want, and this is also highlighting the power that this GPT-4o model has, compared to this 3.5 model, which actually produced, well, essentially trash if you just ask it this really simple question. What we can do here, just to make it a little bit more visual, is I can paste it inside of this view code that I'm running. And then we can see here the result that our model already did just by asking this simple question. So it essentially gave us this really nice form, which already has some validation. We also saw that it has some kind of logic. And this already, as in itself, looks really good. But if you really try to dive deeper into the XML, then you will notice that it's still missing parts, and that's of course to be expected, because it didn't get any more context. It just got asked this question, okay, can you transform this code? And it just went by itself, like, okay, I can do that. But if you take a look at this, if you take a look at the code, and maybe also to the XML, you can maybe see some kind of things that he missed. Because, for example, I am actually not quite sure if he knows that I here have some kind of references in the XML. I'm not quite sure if he actually knows what these references mean. So what I can then do is I can say, oh, do you want to continue? No, I don't want to continue. I want to ask you a custom question. And I will just ask you, first of all, we can say thanks, because we have to be nice to the AI. We can say thanks, and we can say, I notice that not all of the ref tags are used. Please show me a better prompt where I can tell you what the ref tags mean. And I can also then say what it means, so he knows what it means. Ref tags are dynamic parts of the code that should be shown if the conditions are met. So I can ask my model, okay, well, my prompt was maybe a little bit well, not that good maybe. So I can ask him, okay, please tell me how my prompt can become better. And we can see that he says, okay, hey, by providing this prompt, so he says, okay, I have this XML structure with this ref tags, and all of these ref tags, they represent the dynamic part, yada yada. So he actually comes up with a hopefully a better prompt than I wrote. And then all I have to do is just well, copy this part and then put it in my YAML file. And this is the human in the prompt iteration. So I can try to actually, well, develop my prompt so that the model knows what it needs to be doing, because, well, he needs to learn from me, and I also, as a software engineer, needs to learn, okay, how do I tell my model what it actually has to do in order to transform this code. So we're spending more time on this design process than writing the code, because he does that for me. And what my job is as this AI augmented software engineer is actually spending more time in the design phase and trying to set up the best prompt that I can write in order for him to know the most detailed information to be able to produce this code. So what we can do now is try to run it again and see how the code differs by using a more detailed prompt than the prompt that I originally gave it. So here it will take a couple of seconds again. And what you can see already is that it now has a really large focus on these references tags. So I actually expected the code to be largely focused on that, and maybe it leaves out now some kind of validation. So you have to really tell them, oh, I want you to take care of A, B, C, etc., etc. So we can see here that well, he generated newer code, and the first thing that I notice here is that the input is now different. It uses some kind of model, which is nice if you know Vue code that he uses this model. But he also gives you some kind of examples. So he's not really he's just saying, oh, you can do it like this. Here's an example, but I want him to transform all of the code. So I'm actually not happy with this, and I can say, please provide me all of the code. Was my prompt unclear? What do I need to change in order for you to provide all of the code you transform? Something like this. And this process, it can go on indefinitely. So you can keep talking to your model and asking it questions, trying to improve your prompt. And eventually you will be left with, well, this really specific prompt, which you can try to transform your code from A to B. And of course, this is not something we cannot use these large language models to perfectly have this one-on-one transition from code stack A to code stack B. But it will get you very close, as you can see. Like in less than 5 minutes, we have produced some kind of code that essentially already looks a lot like well, this form that we already that we're interested in.
And Jurre, if I look at this and I think back at what we talked about with software lifecycle or software development lifecycle, could you, for instance, grab the prompt that you have at the end of a day and say, okay, I will store this, or I put it in a repository or whatever, and then you can continue the next day, or how does that work?
Yeah, so essentially this is something that is starting to happen more in the people that are working on this actively. Is we notice that there's actually a need to also store the prompts that we have, and maybe also versionize our prompts, because you can imagine that if I'm constantly in this process of iterating on my prompts, then at some point I will maybe like overtrain the model, and I want to go back to a previous state. And if I just have all of these prompts in my typepad, then eventually I will just close my laptop and it's all lost.
Yeah.
So this is actually now something that you see happening in the in the field, is that people are now trying to find ways to store these prompts, also versionize them, and then finally also validating the prompt. So trying to actually get some kind of metrics on the prompt. How good is the prompt, and what makes a prompt good? Stuff like that.
Oh yeah, that makes sense. Okay.
Yeah.
And Jurre, you're trying to get closer to your goal, right? By adjusting the prompt. Have you also tried more like specification by example type method, where you give it both the XML and a little piece of Node.js code that you know you want?
Yeah, exactly. Yeah. So this is just one part of this human in the loop cycle that we can use to try to go actually produce the best results. So this is something that we used in the early stages of the case. And once we actually had a prompt that we were happy with, then of course you can still try to well, actually make the results that the AI produces better. And one thing that you actually can do is also well, not do it yourself, but try to generate also some kind of specifications that you want, or maybe a unit test.
and then try to run these unit tests, and probably most of them or some of them will fail. You can then feed it back the results of these, well, or specification tests or unit tests, and then say, oh, as you can see, like 5 out of 8 tests didn't work. Please try to improve the code such that it works for all 8 cases. So there are different parts in the normal development process where you can use this human in the loop process with your personal assistant, your AI, to actually try to make this process better. But of course, like the end goal here would be that, well, you do all of this nice design work. So you try to cut in the XML in the logical way, and we design the prompt. So there's a lot of time spent there. But at the end of the day, you just want to feed all of this information to the prompt, and then have some kind of code coming out of it at the end, where you can actively work on. So it's actually maintainable by software developers, and they can start developing. So in this case specifically, we're not necessarily building a pipeline that we try to keep running, and every time we are producing something in this blue rig, and then we need to transform it into TypeScript. This is something we do only once.
Yeah, it's a one-time migration, basically.
Exactly. And once we're done with it, we throw away all of the code, and also we throw away the AI code, and then the people can start working actively on the TypeScript development step. Yeah,
I think that's a good one to make sure that everybody on the process understands that it is not some kind of a generation tool for years to come, but it's just a one-time migration, which will also give you some characteristics that you will need to adhere to. You don't need to. It's basically throwaway code, but it has to be just good enough to do the migration, and then from then on you start working on the new stack. So yeah, that's a good one to make clear. Yeah, cool.
And that's of course like the code that we're left with, which we're viewing now. This is code that I, as a software engineer, I can work with this. I can see, okay, it has some kind of logic to it, and I can then like try to develop it and make it better, make it fit all of my process, all my business rules. But like this initial transformation part, that for me as a software engineer, if I have to do that 25 times, I have to go to the YAML, and I have to see, oh, this is a gender field, this is a initials field, and I have to type it all myself. Well, that's the part that I get really sad about if I have to do it myself. So that's nice that we can use generative AI for that, to speed up this process. It's actually that at a certain point, like we had developed all of these nice prompts, and we use this human in the loop process, but eventually you will notice that you're running into some kind of like wall. There's this it didn't get any better, and that's often very frustrating for a programmer. Is if you're hitting a wall, like what happens? You need to start thinking outside of the box. And one question that we had in our mind is, hey, why is code generation actually better for Python in compared to other programming languages? And what we mean with that is we actually noticed that if we asked our model to transform some code, random code A, into Python, compared to transforming it from random code A to, let's say, Java or TypeScript, anything like that, we noticed that the Python one was always better. And I say better, and we did not use any metrics to determine that, but just using like your own knowledge of coding. So we actually tried to find a way to reason why this was the case. And we actually found out that by actually putting a what we call like this intermediate step into our program. So we first started with XML transforming it to Python, and then from Python transforming it to TypeScript. that we actually got better results. And probably the reason for this is that all of these models are trained on open source projects. And there's just a lot of open source projects in Python because that's a very popular programming language. So it just has more training data on it. And that's that is why we call it like the English among the programming languages. So instead of or like translating Spanish to Chinese, we first say, okay, we want Spanish to English, and then English to Chinese. Then you might get better results than having two languages that don't really like interact with each other. Yeah, and of course here we can see that you have this this index that shows that Python is a very popular programming language. And actually, the last thing that I want to end with is actually this quote, and that's something that I really believe in, and that is that there's no AI developer without actually the developer. So I don't necessarily believe that AI is here to really like change the way that I am working as a developer, but it's here really to assist me. And what we notice in this process is that I, as a programmer, still need to do a lot of things, and that essentially sometimes the AI option is not always also the best option. Sometimes you just need to use simple parsing or simple scripting or some kind of combination. So that's actually one thing that I want to give to you guys, is that don't really try to do everything with AI just because it's like this hype term. Try to think, okay, what is the use case? Can I use it? Can I use it here? And how can I integrate this in my like standard developing process and really use it as a tool instead of a solution?
I think it's a really, really great use case. And what I also like about it is that in order to train the model the right way, you have to really think hard about what you're asking of the model and what the end result is going to be that you want. And on average, I think you have to think harder in this case than if you would have just programmed it yourself, because it would be you sometimes have get started on a program while not knowing all the ins and outs specifically, and you just think, oh, I can start coding, and then you run into some issues, and this really forces you up front to really think through your problem, which I think is a great thing. Yeah, so do you have any idea how much faster your team was using this method compared to not using any AI?
Yeah, that is something that, of course, the client was also very interested in. Like using really like rough estimates on our part, we actually were able to bring down this whole process by in terms of development time from the space of we're talking about about going from weeks to actually essentially days. So I think it was something of 40 weeks that the client said he calculated using just normal software engineering, and then our estimates were actually okay. Then with using this AI enhanced process, essentially we can do it in 40 days. So there was this speed up of roughly, like at the top of my head was 80% speed up.
That's a huge improvement.
Yeah. And of course, like then you don't have a finished product, but like the work is already like 80% done.
Yeah, and the difference is so large that you do have that time to
exactly.
make it better and to do the 20% that the AI couldn't do. Yeah,
exactly. And that's
very
also
cool.
like the fun part remains. So the 20% is not like the boring copy and pasting part, but it's actually like oh, the AI calls need to be integrated, or there's a database that still needs to be pulled in, like stuff like that. And that's something like that most programmers get really excited about if they can still do that.
solving
You,
the
you
real
can
problems.
include it in your prompt. Leave the fun parts to me.
Exactly. Yeah, I've never tried that. That's a
Only do
nice
the
thing to
boring
try.
stuff. Yeah, that's a good
Exactly.
one.
Yeah.
All right. Well, thanks so much, Jurre. This was really interesting. So to those watching, please like and subscribe, and we'll see you next time. Bye-bye.